Hey Chem Kids, how's it going? This is Underwood giving you a chemistry webcast for honors chemistry. I actually left this part off of the last video, so this is basically going to be an addition to what you already have been taught. So we're going to go ahead and talk about standard heats of formation. These are the problems that you've probably encountered on the worksheet that you didn't quite understand, and this is how we're going to go ahead and shed a little light. These are actually pretty easy problems. I don't think you guys are gonna have a huge problem with them, but this might help. This equation here. This equation here is just another way of expressing Hess's law. You just need to look and see that the combination of the heats of enthalpy for a particular chemical reaction is equal to the sum of the heats of formation for the products minus the sum of the heats of formation for the reactants. Those are values that you guys are actually going to be given each and every time you do one of these problems. So there might be a table, or perhaps that information might be given in the problem itself. So just get in the habit of pointing out that information and finding it in the problem before you tackle them. Okay, here we go. We'll go ahead and do an example for you. Find the total enthalpy for the following chemical reaction. We've got glucose burning in oxygen with CO2 and H2O as the products. If you remember correctly, that equation that we were dealing with is going to be the heat of formation, the combined heat of formation for the entire process is going to be equal to the sum, which is that weird sigma thing that you guys were looking at, probably didn't know what that meant, of the heats of formation for the products minus the sum of the heats of formation for the reactants. Pretty straightforward, pretty easy algebra. Just need to go ahead and plug in the right values. Notice you'll be given the values for each of the heats of formation, so keep an eye out and make sure you're reading the problem properly. I'll just go ahead and knock this out for you guys real fast and give you the steps. I'm trying to find the combined heat of formation here, so I take the heats of formation for the products. In this case, we have the CO2 and the H2O as our products, so we'll go to the table, find the heats of formation. We sum them together. Just go ahead and give a set of parentheses here for you, and we'll go ahead and multiply the coefficient, this coefficient here. Multiply that coefficient by the heats of formation for CO2, which in this case is negative 393.5 kilojoules. And we're going to add that to 6 times the heat of formation for water, which is negative 285.8 kilojoules. And we'll subtract that entire thing from the heat of formation of glucose, which in our case is 1275.0 kilojoules, and make sure we put in the minus 6 times the heat of formation for O2 gas, and that's in fact 0. So as we go ahead and pop this into the calculator, I like to do it piece by piece just to make sure that you're getting all the right values before we add them all together. So 6 times negative 393.5 is going to result in negative 2,361. 6 times negative 285.8 kilojoules, that's going to be negative 1714.8. We'll add those up later, and then we're going to subtract that from negative 1275.0. Make sure you guys are distributing properly. We'll go ahead and add this section together here for you, and we get negative 4,075.8. We're going to now add that, subtracting a negative number. Add that to 1275.0. And when we do all that, we find out that our combined heat of reaction is actually going to be equivalent to negative 2801 kilojoules per mole. So Those are really straightforward problems. If you have any more questions, go ahead and come in and get some help from us. Make sure you're utilizing the proper mathematical rules for distributing coefficients. Make sure that you're following the order of operations, and that'll help you get this all finished up. I hope this was helpful. This is Underwood checking out.